I ran into an old college friend the other day, and it was wild. We just instantly picked up a conversation from like 10 years ago without skipping a beat.
Oh, wow, just right back into it.
Yeah, exactly. And it got me thinking about how amazing the human brain is, just seamlessly recalling all that shared context. So I want you to imagine an AI assistant that could do exactly the same thing. Today, we're diving into a really fascinating new study called Are We Ready for an Agent Native Memory System?
It's such a great paper. I mean, we are right at this technological tipping point where lifelong digital context is actually finally possible.
Right, because for so long, AI has basically had, well, goldfish memory. We've dealt with these limited context windows where the system just wipes the slate clean the moment you start a new session.
Yeah, you essentially start over every single time you talk to it.
Exactly. But now we're moving toward persistent, personalized AI data systems.
Yeah.
And making that leap requires some serious infrastructure, which actually brings us to this deep dive sponsor, Embersilk.
Oh, a very relevant sponsor, considering the sheer complexity of what we're talking about today.
Absolutely. Whether you need help with AI training or like automation, software development, or just uncovering exactly where AI agents could make the most impact for your own business or personal life, you got to check out embersilk.com for all your AI needs.
Yeah, having that kind of support is key when you're building out these systems.
Right. So let's get into that complexity. We're basically shifting from handing an AI a brand new reference book every morning to, well, to giving it a personal diary.
I'd take it a step further, actually. It's not just a diary, it's a dynamic, self-organizing filing system. The researchers break this down into 4 core pillars.
Okay, what are the 4?
So you have representation and storage, extraction, retrieval, and routing, and finally, maintenance.
Wait, let me stop you right there at extraction because this is where I get a bit skeptical. How does the system actually pull meaning out of what I say?
Well, it's tricky.
Right. Because if an AI has to compress our messy 2-hour conversation into tiny data points, don't we lose the emotional magic of the original interaction?
That is the exact core technical tug-of-war happening behind the scenes. To save space, the AI uses extraction to turn your sentences into vectors.
Which are basically mathematical summaries.
Precisely, or short text bullet points. But every single time you add a layer of abstraction, you do strip away nuance. It's a constant battle between keeping the absolute fidelity of your words and making the data computationally efficient enough to store and search.
So if balancing extraction and storage is that delicate, how are developers actually building these architectures today? I see terms like streaming logs and knowledge graphs thrown around in the research.
Let's compare those two specifically. A streaming log is just a chronological transcript. It just appends everything you say in order.
Okay, so just a giant running text file.
Basically, yeah. A knowledge graph, however, maps out relationships. It creates a data node that represents you and draws a line connecting it to another node that says, hates long road trips.
Oh, that's clever.
Yeah. The study also looked at hierarchical tiers and complex hybrids that mix all these approaches.
And did a clear winner emerge from testing all those models?
The most optimistic finding of the paper is that no single architecture dominates all scenarios.
Really? I would have thought one would just be strictly better.
Well, composite hybrid systems are completely unmatched for fluid conversational Q&A, but those knowledge graphs, they are incredible for single-hop factual recall and seamlessly updating facts about you as your life changes.
But wait, computing power gets cheaper every single day. Why wouldn't we just brute force it?
How do you mean?
Like, why not build the most complex, highly structured knowledge graph possible and just throw the kitchen sink at the problem to cover all our bases?
Because of the operational reality of time, highly structured systems suffer from massive index construction times.
Meaning they take too long to build the memory.
Exactly. Imagine trying to build a perfectly cross-referenced library catalog while someone is actively talking to you. It creates unbearable latency. You'd ask a question, and the AI would freeze for 10 seconds trying to update its map.
So it completely ruins the illusion of a natural conversation.
Precisely. That's why the study points to a strategy called conservative consolidation.
Conservative consolidation.
Right. Instead of obsessively mapping every single typo or passing thought you have into a complex graph, the system should just reliably connect the major stable dots of your life.
So keep the memory efficient so the conversation actually flows.
Exactly. We are actively solving the puzzle of creating truly stateful, lifelong AI companions, and it's just an incredibly exciting frontier.
That is such a smart design philosophy. Don't over-engineer it, just focus on what actually matters.
Mhm.
And that leads to an incredibly thrilling concept for you to chew on as we wrap up. Imagine a future where your personal AI quietly tracks the evolution of your creative ideas over decades. By connecting those major dots, it could help you rediscover brilliant, fragmented thoughts you had completely forgotten you even had. A true, lifelong, intellectual companion.
That is a beautiful way to look at it.
It really is. Well, if you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.